Okay, today we're going to talk about how we translate word problems into equations. Okay, and we're using the standard AA6, which is analyze and solve verbal problems whose solutions require a linear equation in one variable. Okay, so if the larger of two numbers is 4 times the smaller, or the larger of two numbers is 4 times the smaller, if the larger number exceeds the smaller number by 15, you must find the numbers. And what's implied here is that you have to do it algebraically. Okay, so it's implied that you have to do it algebraically because it's an algebra class. Okay, so the two things that you're looking for is the larger number and the smaller number. Okay, so I'm going to make this little table here. The larger number and the smaller number. Now there's two ways that the word problem up there suggests that you can write these. So the larger of two numbers is 4 times the smaller. Now remember, oftentimes when you have a sentence, the last word in the sentence is a good choice to make your x. So I'm going to make the smaller number my x. Okay, and this column is the information I get from the first sentence. And this is the second sentence. Oops. Sentences with a C. Okay, so in the first sentence, it says the larger of two numbers is 4 times the smaller. So if the smaller is x, 4 times the smaller would be 4x. Okay, and in the second sentence, it says if the larger number exceeds the smaller number by 15, so the larger number exceeds the smaller number by 15. So again, I'm going to make the smaller number my x because that's how I start working to find my larger number. And then the larger number exceeds this by 15, so that means that the larger number can be represented here with x plus 15. Now, once we filled in the table, we have to look to try to figure out how we can make an equation. Right? So since we're working with two of the same numbers, there's a couple of different equations we could have. We could say, well, both the smaller numbers are the same thing in this case. Okay, so that equation would be x is equal to x. But that doesn't really, that's always true. Okay, that doesn't help us solve for x. So that's not helpful. So let's look at the other equation, which is, okay, this is one expression that represents the larger number. I'm going to set that equal to the other expression that represents the larger number. So this is like saying the larger number is equal to the larger number, which we know is true. Okay? Alright, so I'm going to start solving this. Solve for x here. Let's see. First I'm going to subtract x from both sides. So I have 3x is equal to 15. And then I'm going to divide each side by 3. And I'm going to get x is equal to 5. Now, x is equal to 5 means the smaller number is equal to 5 because that's what I was solving for. So the smaller number is equal to 5, and the larger number must be equal to 20. Okay, so the smaller number is equal to 5 here. Whoops, put that in. Smaller number is equal to 5, and the larger number is 4 times that, which is 5. If I look at the second representation, again, the smaller number would be 5. And if I put x in here, I'd have the larger number be 5 plus 15, which is 20. So both of the representations come up with the same thing. So the numbers are 5 and 20. Okay, the second problem is this one. In his will, Uncle Clarence left $5,000 to his two nieces. Emma's share is to be $500 more than Clara's. How much should each niece receive? Okay, again, I'm going to make a table. Okay, so I have this table here. And I am looking for what Emma's share is and what Clara's share is. Okay? Alright, so I actually don't even really need to have, I only need to have two columns here. One specifying what Emma and Clara is, and then one with the representation. So Emma's share is $500 more than Clara, means that I should start with Clara. So I'm going to put the X on Clara. and go backwards. So from Clara, if I add $500 more, I would get to Emma. Okay? Now, if Uncle Clarence left a total of $5,000, that means if I add Emma's portion and Clara's portion together, I should get $5,000. Okay, well, what's the expression that stands in for Emma's? That would be x plus 500. And the expression that stands in for Clara's is x. And altogether, that should be $5,000. Okay, so I have my equation here. So I'm going to start combining terms here. So I have 2x plus 500. Oops, that's just 500 there. Is equal to 5,000. Okay. If I subtract 500 from both sides here, I'm going to bring it over here. So I'd have 2x is equal to 4,000. Let's see, 4,500, right? Right, and so I divide by 2, x is equal to 2,250. Okay, so that's Clara's share here. So Clara's share is $2,250. Okay, and Emma's share is $500 more than that. So that would be 2,750. And if you run those numbers right back through the equation, you'd see that they satisfied all the things they needed to. So Emma's share is $500 more than Clara's. So yes, Clara's is 2,250. Emma's is 2,750, and together they add up to $5,000, which is also a criteria. Okay. All right. The next problem is Raoul has 25 coins, all quarters and dimes. If the total value of the dimes and quarters is $4.90, write and solve an equation. That should actually just be an equation right there, to find how many dimes and quarters Raoul has. Okay, so I'm going to make a table. And this will be dimes, and this will be quarters. Okay. And this one, this row will be the number, so the number of coins, and this will be the value of the coins, okay, because there's two different things. Now, let's see. He has 25 coins total, all right? So it doesn't matter where you put the X. You could put it on the dimes or you could put it on the quarters. So if I put this on the dimes, then I know that the quarters must be 25 minus X. Okay, so for instance, if I had 12 dimes, then to get the number of quarters, I would take 25 and I'd subtract 12 from it to get 13 quarters. Okay, so we don't know the number of dimes, so I would use X, and the expression I would use for the quarters is whatever X is, subtract that from 25, and that gets you the remaining parts. All right, so let's see. So that's the number of the coins. Notice also that I could check that, so I know that that has to add up to 25, but X plus 25 minus X, well, that simplifies to just 25, so that's another check. Okay, now the value, now you have to be careful here because this is written in dollars, so either you write this in cents, which would be 490 cents, or you have to, whoops, or you have to write it, you have to keep it in dollars but write the value in cents. Okay, so that would be cent right there. Oops, I keep switching. That would be cents, or you have to, so you either have to, you have to choose whether to put the value unit here as dollars, okay, or as cents. Now I'm going to use dollars, so the value of the dime, so however many dimes you have, to get the value, you have to multiply it by 0.10 or 0.1, because that's 10 cents, right? $0.1 is the same as 10 cents. Okay, now this quarter one is a little trickier because quarters are $0.25, right? So this expression represents the number of quarters. So to find the value of the quarters, you have to do 0.25 times 25 minus X, because 25 minus X was the number of quarters, okay? All right. So make sure you take a second and try to make sure that makes sense to you. Alright, so now what we know about the value is together they must equal $4.90. So let's make our equation. So however many dimes you have times 10 cents plus 0.25, the value of the quarters, times however many quarters you have, must equal $4.90. Okay, so the first thing you have to do here is you have to distribute. Right, so you have 0.10x plus, 0.25 times 25. The way you do this is you pretend it's a whole number, so 25 times 25 is 625, and then you take into account that this is 0.25. I disregarded 2 decimal places to the right, so I have to go back 2 decimal places. So 0.25 times 25 is 6.25. So that's subtracting 0.25x, and that must be equal to $4.90. Okay, here are your like terms. Alright, so 0.10x minus, so let me just do a quick keep change here. Okay, that's 0.10x plus negative 0.25x plus 6.25 is equal to $4.90. Okay, and this right here gets you negative 0.15x, okay, plus 6.25 is equal to $4.90. Okay, subtract this from both sides. Okay, I'm running out of room here, so I'm gonna do it over here. So remember, that's 6.25 minus $4.90, but then you make it negative. Right, so that's 5, this will be 12, and 3, and 5, and 1. So this is, the equation that you have left is negative 0.15x is equal to negative 1.35. Alright, so I'm going to erase some of this work so I have some room here. Now, you've got to divide both sides by negative 0.15. So because you have 2 negatives, you have to make that into a positive, and so that now this becomes just 1.35 divided by 0.15. Remember, the shortcut for that is 100 over, multiplying each one by 100 over 100. So it's 135 over 15. Okay, so let's do some more work here. 15 goes into 135. Well, I guess we just have to, so we have 15, 30, let's see, 15, 30, 45, 60, 75, 90 would be next, right? 90, 105, 120, 135. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. Okay, so x must be equal to 9. After all that work, you find that x is equal to 9. Alright, so that means that you have 9 dimes, and you have 25 minus 9 quarters, so 25 minus 9 is 16. So you have 9 dimes and 16 quarters. Now that makes sense, because if you had 9 dimes, you'd have 90 cents, and if you have 16 quarters, you would have $4, so $4 plus 90 cents is $4.90. Okay, and that was the last problem that we're going over for this lesson.